So it says each of these graphs has a line symmetry. Graphs that have line symmetry can be folded along a line of symmetry so that the two halves match. Two halves match. What word do you think I was going for there? I'm thinking equally. Equally. I like that more than exactly. So they match equally. Some graphs, such as an ellipse, have more than one line of symmetry. So, do you guys agree the line of symmetry in this first one, I'm going to do it in red. Boom. Right there. Do you agree I could fold this over and it lands on top of itself? Lines of symmetry could be horizontal, right? Fold that over. It's like folding a sandwich over a hot dog bun. This ellipse over here has got two different lines of symmetry, okay? Point symmetry is something where we spin it, really. If you can spin it and it's still the exact same image, it's got symmetry around a point. When you kind of, let's say, spin a basketball on your finger. The most common type of point symmetry is at what point on a graph? It's always going to be the origin. The origin. This means that a figure is symmetric with respect to a given point if it can be rotated 180 degrees about that point and still be the exact same figure. So example, this S, if I rotate 180 degrees, check this out. If I rotate 180 degrees, is it still the same S? Yeah, so that one's got point symmetry. What about this line here? If I rotate this 180 degrees, is it still the same line? Yeah. What about this cute little hyperbola? If I rotate this 180, is it still the same thing? Yeah, and finally, this cute little graph 1 over x, rotate that 180 degrees, then it's got point symmetry. So all of these are point symmetry. Okay, peeps, for something to be an even function versus an odd function, these are even, this one's odd. Which one do you think has the line symmetry? Which one do you think folds over a line, even or odd? Even's going to fold over that line. So I'm going to say that the even functions, they're symmetric about this y-axis. And just a reminder, the y-axis is that vertical one. All of these, if you folded this over the y-axis, are they going to land on themselves? Yeah. Odd functions are symmetric about that origin. The odd functions have that symmetry through that point. They've got that point symmetry through the origin. And let's talk about what the heck those points would be. Let's talk about what makes something even. If this was the point, let's say that this was the point 2, 4 on this even function. What would the point be over here? Negative 2 what? Negative 2, 4, right? If this was the point 1, 7, I'm doing this right here. What would this point be? I'm just kind of making these up. Negative 1, 7. So with even functions, when the x's change, the y's stay the same. When the x's change, the y's stay the same. So if this was the point 1, 2, 3, 4, let's say that this is the point 4.50. What would this point be over here? Negative 4.50. So again, the x's change, the y's stay the same. In an odd function, let's make up this point. Thomas, what point do you want this to be right here? I don't care. Make it up. 0.7? Oh, okay. 0.7. What's the y then? 0.5. Okay. If that's the point over here, what would be its reflected point? Anyone have any idea? What would those values be based on his beautiful point that he wrote up here? Both negative. Well said. If x was negative 0.7, my y would also be negative 0.5. Okay. What about this guy here? What do we want this point over here to be? Make it up. What do we want this point to be? Drew, give it to me. What do you think? Right here. Whatever. Maybe no decimals. 2? What about the y?
3.
Sure. If that's 2, 3, what are we going to say its revolved point's going to be? You know it. Then this is a cute little graph of y equals sine of x. If we go down here, this one I'm actually going to use this point. This is pi over 2, 1. That's pi over 2, 1. What's its reflected point going to be? You got it, girl. So, you guys, with even functions, So with each of them, the x's are always opposite, right? 0.7, negative 0.7, 2, negative 2, pi over 2, negative pi over 2. Even or odd, the x's are always opposite. In an even function, your y's stay the same, 7 and 7, 0, 0, 4 and 4. But in odd functions, 0.5, negative 0.5, 3, negative 3, 1, negative 1. In odd functions, the y's are opposite. So the x's are always opposite. The y's are opposite with odd. Let's flip it. So now on this one, I wrote it a little differently. I'm saying, look at this notation. Ready, Lloyd? Look at this notation. I'm saying if you put in the opposite for the x, which is what we were just looking at, when my x changes signs, guys, what is f of x fancy for? F of x is just fancy for y. So if we just remind ourselves, so if f of x is equal to y, this is just fancy for y. In an even function, my y stays the same when my x is opposite. And a way to say that is if my function has the point a, b. In an even function, when my x is opposite, the y stays the same. So when my a is opposite, my y stays the same. With odd then, with odd, when my x's are opposite, we get the opposite of my original. We get the negative of my original. So if my original point had a, b, the odd point would be change the a and the b. So another visual of it. Do you guys agree these are, Thomas, you with me? Even means that we reflect over that y-axis. And odd means that we rotate around a point. And it's the exact same graph as before. We get the same graph. Okay, so now we got to decide, is x to the fourth an even or an odd function, or maybe neither? Let's take it to a graph. So we have to prove it. Let's just sketch it first. X to the fourth, we know looks like this. It's just a parabola, but it's just a little flatter on the bottom. But anything with an even exponent is going to have this shape. This is x squared, x to the fourth, x to the sixth. And I'll even show you x to the fourth. This one's x squared. This one's x to the sixth. So they all have the same shape when they've got that even exponent. Check it out. They just get it like a little squattier is how I just describe that at the bottom. So all of these are even, and that being an even exponent is a good hint. Here's how we got to prove it. Here's how we got to prove it. We got to go say, all right, that's just the same as my function. If my function was x to the fourth, I just rewrote my y as f of x. Just rewrote that. You guys, in order to prove it, we got to go plug in a negative x in for my x. So I need to replace every x with a negative x. Every x has to have a negative. And then we just have to simplify it. When I plugged in a negative x, what happens if I take any negative number to an even power? Would it stay negative or would it turn back to positive? Any negative number to an even exponent will always be positive. And here's what we got to do with that info, you guys. You got to look at what you started with. We started with f of x equals x to the fourth. Did we end with that same thing? Did my x to the fourth stay the same? Because it did, you're going to say, when I plugged in a negative x, I got what I started with. When I plugged in a negative x, I got exactly what I started with. And this statement, you can see it right up here. This statement, you can see here. You with me, Thomas and Drew? You can also see it here. This means it's even. So this statement, you'd say, therefore, it's an even function. We need this validation. We can't just say, oh, even exponent is going to be even. We got to go through these steps, which I know is annoying, but we just have to start getting familiar with it. Let's jump to this one, and then we'll come back to the middle one. X plus x cubed. Any predictions? Let me graph it for us. Any predictions? What are my exponents? Even or odd? They're odd. So what's our prediction? We're thinking odd. Does this look like it's going to be odd? Can I rotate that about the origin 180 degrees and get what I started with? I'd say so. So let's do it. Here's what we got to do, you guys. My original function was x plus x cubed. Over it. All right. What we got to do every time, how you start all of these, is we always replace our x with a negative. We replace this x with a negative, so we got to replace every x with a negative. Anytime I've got a negative number to a power, I'm always going to put it in parentheses. And then we got to simplify. We got to simplify this, y'all. Negative x, I can't do anything with this negative x. I can't simplify that any further, so it's going to stay. What about a negative x to the third? Would it turn into a positive or stay negative? Stay negative. Any odd exponent will always stay negative. So now I've got minus an x cubed. Yeah? Okay. Did I get what I started with? Is this what I started with? No, but is it exactly the opposite? Is everything's sign the opposite? Yeah, so here's what your statement always is going to always start with. When I plugged in a negative x, it's always going to start with that. We didn't get what we started with. We got the opposite of what I started with. I didn't get f of x, I got the opposite. And the opposite we just show in terms of a minus sign. And anytime we've got that statement, I look right here. Oh, when I plug in a negative, I got the opposite of what I started with. So that's going to be an odd function. I'm going to say, therefore, it's an odd. And we could have drawn our little graph, which looked like this. And again, an odd function, if we rotate 180 degrees, it gets me what I started with. So I feel good about that. Middle one, predictions, x plus 2. You're saying neither. And is that just a process of elimination? Right? I don't blame you. X plus 2, you guys do agree that that would just be up to, my slope is 1. You don't have to be completely accurate, but that would be a sketch of this graph, right? And if anything, do you agree it definitely doesn't have line symmetry? If I were to fold this over that y equals, my y-axis, it would look like that, and it's not landing on itself then. What if I were to revolve it about the origin 180 degrees? Is it the same thing? Would it land on itself? No. This one down here has a negative y-intercept. This one up here has a positive y-intercept. So you're right, it's going to be neither, and this is how we prove it, Steph. We say, all right, my original function was x plus 2. I always just like to write it in terms of f of x personally. Then the first step we always do is plug in a negative x for all of my x's. Every x gets replaced with a negative. Then we simplify. Can I do anything to this? Can I simplify it at all? No. So then you have to compare your simplified answer to my original. Do they match? Are they the same? If they were the same, it'd be even. Is every single thing opposite? No, the x's are opposite, but the 2's are not opposite. So since the whole thing's not opposite, we're going to say neither. Predictions on this one, this has even and odd exponents. Anyone have a prediction? Can't hurt. You waiting to see that graph? Plus x to the 4th. I appreciate a guess. Ooh, even, odd, or neither. Yeah, it's going to be neither because this little pimple that this thing has, right? So when I go to sketch this, if I were you guys, I'd just be like, ooh. So it can't fold over the y-axis because this little pimple wouldn't land on itself. And if I rotate it 180 degrees, it's definitely not going to look like what it started with. So the answer is neither. Here's how we're going to go prove it. We're going to go plug in a negative x for all my x's. If you don't have parentheses, it is incorrect because it wouldn't simplify the same if we didn't have parentheses. And when we simplify it, what's a negative to an odd exponent going to simplify to be? Negative or positive? Negative. So that's just going to be a negative x cubed. A negative number to an even exponent is positive. And then you got to compare what we started with to what we ended with. Do they match? If they matched, it'd be even. Do they match? No. Are they both? Is every single thing opposite? No. So therefore, we're going to say, it's neither. I dig it. Let's do it. Let's show ourselves why. Here's the original. Obviously, it's not going to be even because even would have to get reflected over that y-axis, and it would not land on itself. No, no, no. But if I rotate it 180 degrees, it's the exact same graph. So, again, that first step, we just plug in a negative x in for all my x's. This is a good simplifying reminder. Question, is this the same as this? I just made up these numbers. Are these the same? And is that the same as that? Right? We get one negative sign, either in top or bottom or out front. Is that the same as this? No. So anytime you're given one negative sign, I don't care where it is, it does not apply to both, right? So I'm going to say, does not equal that. So how could I rewrite this guy? Is that the same as negative 1 over x? Therefore, did I get what I started with? No. Is it completely the opposite? Yeah. So we're going to say, because when I plugged in a negative x, I got the opposite of what I started with. The opposite of what I started with. I started with an f of x. I got the negative version. And then because I'm fancy, I'm going to say, therefore, it's odd. Mr. Roberts is just going to write odd. Boring. Here we go. Last one. Let's take a peek at it first. Boop. We got x over, and then I'll do 1 minus x. And when I graph that, what do you think? This one is like this. It goes here, and then it goes here. Predictions. Even. If you fold it over that y-axis, will it land on itself? No. Odd. If I rotate this, will it land on itself? If I take this guy 180, I think he's going to land over there. Let's check. Whoosh, right? So our guess is going to be neither. We got to go prove it. We got to go plug in a negative x for all of them. Negative x in for all of them. And then we got to simplify. When I plug in a negative x, we get negative x over 1 plus x. Do you get the same as what I started with? Or everything the opposite? Is the top opposite? Yeah. What about this 1? 1's not opposite. Is the x opposite? So it's like so close, but is it everything the opposite? No, so then we got to say neither. And that's what we predicted. Okay, so I'm going to have you guys do these 6. You can get rid of 20. You can also get rid of these. I think these are kind of dumb. I want to do these harder ones with you real fast. Let's do this one together to remind you guys. If I did x is to the 2/5, does anyone remember how those exponents go? Blank over blank. I want to do number 16 with you. This is the graph of it. Does that look even or odd? It's looking like it's going to be even because it's reflecting over that y-axis. My guess is even as well. And just to remind you guys, this is power over root. So this is x to the 2nd power, and then it's to the 5th root. Another way, if it might help you, is the 2nd power, and then 5th root means like this. If that helps you visualize that. So that's my original function. And then to solve these, we got to go plug in a negative x for all my x's. So I'm going to go plug in a negative x. And what would that get if I simplified that? What's any negative squared? Positive. So wouldn't that just get the 5th root of x squared? Or x to the power over root? Is that what I started with? Yeah. So we're going to say, because when I plugged in a negative x, I got what I started with, f of x. That's how I know it's even. So I'd say just do those 4. So we got some on the front, some on the back.